And I'm delighted to be joined on stage now by Shelly Van Dyke, who's the head of Automotive Processing Strategy at NXP. Shelly, tell us, what are the key areas at the moment that NXP is working on specifically for automotive?
Yeah, so thanks, Peter. NXP is probably a name you haven't heard of that much in automotive, but we've been in cars as long as electronics have been in cars. And about half of our business is automotive. So last year, the $13.2 billion, that was $6.9 billion in semiconductors. And really, we're in about every system in the car. Leadership areas for us include things like domain and zonal controllers, right? And leading into vehicle compute, so for software-defined vehicles, and really that underlying, like, how do you build that architecture? Also, some areas like radar systems and ADAS, we're a leader there. And in electric vehicles, battery management, traction inverters being in there. And then one that I like to often cite that people don't think about, but your smart car access, right, or your remote. And really how that is evolving and going onto your phone. So we're in parts of that, and there's a whole bunch of other areas that I haven't mentioned.
So one of the things I want to ask about chip development is that automotive hardware lasts generally for a long time, right? And development cycles are quite long. Chip technology is changing very fast all the time.
Yeah.
How do you reconcile the need to have the latest tech in a car if the cars take a certain time to develop and then have to be on the road sometimes for decades?
Yeah, so great question, right? So really it comes back to looking at what is the vehicle, right? A vehicle is a system of systems, right? So we often think of it as there's tens to 100 or more systems within the vehicle. So unlike most consumer devices that are fairly simple in the number of systems in them, we're looking at a whole bunch. An average car in the world a couple years ago was about 1,000 per car. I cite that because it's easy to remember. It's more than that for most of the cars that we drive today, right? And so when you think about it, you can't just redesign all the chips, that whole 1,000 every generation. That would be absurd, right? And it would be ineffective in cost, right? The semiconductor industry has really over time been about putting more technology into a smaller area on an economically sound basis, right? So shrinking what needs to be shrink, what gets benefit, and putting the R&D there. Now, really on the leading edge, there's only a handful of chips in the car that are leading edge. And so that's where that focus becomes. And when you look at, as we've heard from some of the panelists and from Ferrari this morning, they're focusing their R&D in certain areas. And so the chip development kind of follows that of where are the problems, what are we trying to solve together, and really understanding that and the use cases and what we have to go do there. So that's when we end up focusing, and then we reuse a lot, right? Which then brings the additional challenge of, okay, you're reusing legacy technology. Okay, you have to fit that in. So you pick up the new, right? And even the latest cars on the market are still using some older technology in there. And so you have to embrace both, right? And I think we all know from generations of, again, consumer devices and how that goes, what you have to do. The added complexity you have in the car is that when you're in the car, you expect it to work all the time. And as we see, even now, right? Yeah. Even now this morning, right? Microphone, iPad questions. If you were paying for that in your car, you wouldn't. That happens 2 times. You're like, I'm not paying for it. I'm taking it back. I want a software fix, right? And so, and especially in the safety and security of the vehicle, which frankly most people don't even think about. And we have to really spend the time and the effort and the focus there. And that's where, as the last panel mentioned, the ecosystem is really developing and shaping. And how do we do that together so we can do it faster and take advantage of all of this?
Now, you mentioned software updates in that. Is there a way that you're thinking about future-proofing your chips so they can go in and they can be updated to unlock certain features later on once they're ready? Or is that something that is always going to require a hardware upgrade because that's more difficult?
Yeah, so and unfortunately, at a certain point, you can future-proof to a certain point, but there's the economic equation, right? I mean, we can add all the performance headroom that people want, but they don't usually want to pay for that all up front. And so can you do it by making the architecture where, okay, then it's on a board and you slot it out with a new board, right? And so then indeed, how do we make sure that the enablement software can recognize, oh, instead of, 2 8-core devices, I now have 2 16-core devices I've updated with, right? So that's possible. And certainly in the enablement software, we're doing that. And then also when we work with our customers, tier 1s, OEMs, we're also looking at how are they planning this? What are the use cases they really see? What's the data say about where the usage is going to be higher, right? And they're definitely taking that information of, oh, if this is only 5% used, they're not building in headroom for that 5% so much. They're building in headroom for the bigger cases, right? So that's really where it comes about.
Can I ask you about development speed? Because kind of 10 years ago, cars were very unconnected. Today they're very connected. That's the technical terms. But are you seeing the pace of chip development? Have you already hit the plateau? Is it slowing? Is it as fast as it was 5 years ago? And what's the current area of focus?
It kind of depends on which chip technology you're talking about. So like I said, there's certain areas, so very heavy analog mixed signal doesn't have, it doesn't scale as quickly. You don't get the economic benefit from cramming it into the latest node. Also, the latest nodes, frankly, are developed for other industries. They're developed for mobile, low power, or they're developed for compute, high performance, right? They're not necessarily developed then for automotive grade, where we have the quality and robustness. And, even with electric vehicles, some of the requirements are changing. Maybe the temperature range isn't as high, but it's still fairly high, right? You still want to be able to turn your car on whether you're in Phoenix or Alaska or somewhere like in between, right? And so it's really about focusing in on where do we need the latest. And so chip development is happening at about the pace that, frankly, it's been happening over the last, that part, the 5-10 years. That hasn't changed of, it's 2 to 3 years on the latest nodes. But we do see more focus on, okay, let's bring in the specialty aspects of that and bring that in. And what we also see is a faster take-up of simulation and virtual development, right? So we have to have that ready earlier, and we have to maintain it longer than we used to have to, right? So it used to be you did the virtual model until you got the hardware model, and then you just went from hardware. Now we need to maintain that over time, but we also have to have it available before we've even designed the chip, right?
Now, obviously, there is hardware involved, which means you physically have to make them, which means you have physical supply chains. Now, we know the chip industry has been a bit of a bottleneck in the car industry. Yeah, exactly. Over the last couple of years. You obviously weren't solely responsible, but is that now over? We're getting a sense that it's getting better.
It's definitely getting better, and I know we mentioned it on our earnings call, but we see fewer number of restriction points. There are still a few. And really what is going to solve it for the long term, and this is where we're focusing with our customers on really understanding what are their long-term needs. And this is where the partnerships for the new vehicles, what do we want to build, and then also, frankly, the reducing of the complexity of the number of models and variations is going to help with that, because it'll make that a little bit more predictable and traceable, right? But we were hit with, frankly, triple whammies of underinvestment structurally in some of these nodes. Also, the sudden, start-stop in the pandemic. And then, frankly, it was a huge tipping point where ADAS was really coming up, and now all of a sudden electrification electrification coming up, and both of those use a lot more chips, right? And so when you're making fewer vehicles, but you're putting more content per vehicle, it's a big change. So we're trying to look out for that and really having those conversations and agreements, and really having multi-way conversations, not just one way, which I think before the shortage was more common, and now it's more common that we share that amongst our suppliers, OEMs, tier ones, and really double check each other and discuss what makes sense.
Some of the car makers started thinking differently about the way that they source chips as a result of this, thinking, do they try and bring more in-house? Do they try and do more co-development? Do they even try and do some of their own fabrication? Is that something that you've seen, and do you think that might be something that affects you in the future?
So we've definitely seen them thinking about the way that they partner with chip companies. And look, I think everyone will always consider make versus buy, but for the large part of that 1,000+ chips, it'll be buy. Because it's just not economically reasonable to do one. On the ones that they choose to make, it'll be similar to other industries where the return on investment is because of returns that are outside of the chip equation, right? And so it's really about, it unlocks some advantage in software, it reduces development, it enables greater reuse, something like that. And so that's what's really going to happen. And what we've seen in our business is more where we talk to them now about, okay, you're trying to do this software-defined vehicle, right? And a software-defined vehicle isn't only what consumers interact with. It's also that foundation of the vehicle, right? And Mr. Vigna from Ferrari talked about it as performance, as that aspect of it. It's a piece that people don't often think about, but we're really working with OEMs about what are they trying to do in their platform to support that, how much headroom do they need, and what does that start to look like on the vehicle compute that they want to have in there, the zonalization, how are they doing that, how are they simplifying the network, when, what are they trying to simulate, and what use cases do they think they really want to enable. And so we have announced, some partnerships on that, and then we've also not announced some partnerships on that. So, but there's a lot going on that discussion.
One more question on the shortages, which is that many of the car makers found that actually when they wanted chips, there were chips, but they weren't getting them. They were behind other sectors in the queue, sectors that buy in larger amounts than the car industry do. Has that been readdressed? Has that changed for the long term? Or do you think the car industry is still going to be pecking behind the Samsungs of the world when it comes to buying in the future?
Yeah, so, the interesting issue, I do think it will be partly, it's better now because there's more education, and frankly, I've spent a lot of my time just educating people about what I call Auto Semi 101. But we've been about 4 or 5% of the industry, right? Well, auto semiconductor is going to be the fastest growing spot in semiconductors, through this decade. That's been said by a number of external parties. So there will be more attention, more focus there. The challenge for the suppliers into that industry is that auto, the peak of auto tends to be several years after you've done the first development, and then it's a very long life. And frankly, again, with software-defined vehicles, that car is going to live longer if you personalize it to you and it's keeping up with everything that you want to do and all of your updates, you're going to keep it longer. And so we have to maintain that, for even more time. And so really it's about educating the supply chain that we have to invest in those technologies and we have to maintain and support them for a longer amount of time. And that's been also part of the, even with the CHIPS Acts in various regions as well, helping them understand what are the areas that are going to be needed and what needs that investment.
Thank you. We've got about a minute left. I want to ask a final political question, geopolitical question. A lot of chips are made in Taiwan. Right? We've seen the auto industry pulling itself out of Russia. A lot of people are now thinking about how they set up global operations in the event of something happens to Taiwan. Are you changing what you're doing there? How are you thinking about that whole issue?
So, we're really looking at what each customer needs, right? And having that conversation, because the automotive industry, is not converged on one way of doing anything. They're not all building the same vehicle. Their footprint isn't in the exact same regions. And so, most of them are global companies. We're a global company as well. And so really it's about how do we figure out what works best for them and how do we navigate that? And that's the conversations that we're having.
Great, thank you very much. Shelly from NXP, thank you very much.
Thank you.
For your time.